Let us now look at an example of a stateless session bean. We have something called as a converter bean here, which converts from dollar to yen and yen to euro. So first we have a home interface. In the home interface we have a create method which throws remote exception and create exception, and it returns a converter type of object. Converter is nothing but a remote interface which has two methods, dollar to yen and yen to euro, which take double as parameter and return a double value in return. And these methods throw remote exception. The converter EJB class implements a session bean as we are writing a stateless session bean. Now where do we specify whether stateless or stateful session bean? Because here we just said it's a session bean. We declare whether it's a stateful or stateless session bean in the deployment descriptor file, which we are yet to focus on. So here notice that we are implementing dollar to yen and yen to euro methods, and please also note that we are not using throws remote exception here. It's not required because it's not a direct implementation of the remote interface. We do have EJB create, EJB remove, activate, passivate and set session context methods coming from the session bean interface. They are all callback methods. Since we do not want to implement anything out there, they are all do nothing methods. If at all you want to access a session context variable across the methods of this class, then declare a session context variable in this class and initialize it during the set session context method call. Once the bean class is ready, we have a class client, converter client, which uses this bean and calls a method on the bean. So in the main method we are creating a properties object because we need to go and do a lookup into our JNDI. In order to look up into our JNDI, we need a JNDI context. We need to specify, while creating an initial context object, the JNDI factory name and the machine and port number at which the server would be listening, which runs the JNDI. So therefore, we create a properties object which will hold two variables, that's the initial context factory and the provider URL. The initial context factory variable will hold the JNDI context factory name and the provider URL will hold the URL. In this case it's T3://localhost 7001. 7001 is the listening port of WebLogic server. We are creating an initial context object by passing the properties object as parameter, calling the lookup method, specifying my converter. My converter happens to be the JNDI name for the bean. So we get a home interface type of object. Now using the home interface object, we call the create method. The create method will return a remote interface type of object, using which then we can invoke the business methods dollar to yen and yen to euro. Then we are also displaying those values to the console. Then finally calling converter.remove. This is the client program. Now moving on to the deployment descriptor files, we have EJB jar.xml, which is a common XML file for all the servers. Then we will have a server specific XML file. The EJB jar.xml file defines the component. So we have EJB jar as a root element there. An enterprise bean element has a session tag which takes a EJB name, home, remote, EJB class as tags to map the home interface, remote interface and the bean class. So, EJB name is an alias name given for this particular session bean. This is the home interface, remote interface and the bean class which we defined. Notice using a session type element, we declare which type of session bean it is. That is, in this case it is a stateless session bean. This defines a EJB jar.xml. If we move on to WebLogic EJB jar.xml file, we see that the same EJB name is utilized out here that we specified in EJB jar.xml, that is stateless session. Then using the caching descriptor, we can define how many instances we want in the pool, and that is maximum number of instances and minimum number of instances. So, accordingly the container will maintain the number of instances in the pool. During the time where there is less traffic to the container, the container will take care for that particular bean to reduce the number of instances. As and when it is required, it can increase the number of instances in the pool. The JNDI name is also specified out here for the bean using the JNDI-name element, and that is my converter. And we have a client. Client also did a lookup for my converter and then invoked the methods of the home interface, remote interface, and so same JNDI name is used by the client when he does a lookup for the home interface. So, this is an example of a session bean, stateless session bean. Okay, now that we have seen the stateless session bean, home interface, remote interface, bean class and the deployment descriptor file, let us see how to execute this particular program. We need to compile these code and then put it into an appropriate jar file, and the jar file should be placed into an appropriate place in the application server. Now, we need to make use of the application server to execute our enterprise beans. Now, what is the difference between application server and a web server? A web server consists of only the web container, whereas an application server consists of your web container, your EJB container plus other services. First thing that you need to do is we are creating a temporary directory called build, and under build meta-inf directory. Copy all the XML files to a meta-inf directory. Then compile the bean component classes. So, we do a javac -d, we compile it into a build directory, the converter.java, converter home and converter ejb.java files. These are the three files involved in building this particular component here. Once this is done, we move into a build directory, create a jar file of the meta-inf directory and all the classes under the build file, place it into a jar, and here in this case we are placing into std ejb basic converter.jar. Then we are moving back to the parent directory of build. You now have a jar file which consists of meta-inf directory with the XML files and the class files required for the component, bean component. Next thing is, using this jar file, you need to generate the EJB home, EJB object, classes, and you also need to generate the stub classes for them. In order to achieve this, we use weblogic.ejbc command. So, we use java weblogic.ejbc minus compiler javac. We refer to the jar file which consists of all the files which have to be used to generate the EJB home, EJB object and the stub classes. So build slash the converter.jar file. So this EJBC WebLogic.EJBC compiler will read the contents of the jar file, read what you have written in the XML file, and accordingly generate the home and EJB object classes, and from those classes it will generate then the stub classes, and then put them along with all the rest of the files into a new jar file, and that we are calling as EJB basic converter. Now where are we placing this jar file? In case of WebLogic, examples domain, we place the jar file under the applications directory of the domain. So in WebLogic, if we go to BA, WebLogic 8.1, samples, domains, we are talking about the examples domain, so we go to examples. It has applications directory. This is where we need to place the jar file, that is the component jar. So when we start the server, automatically this jar file will be loaded or deployed onto the server. If suppose you keep the jar file elsewhere and not under applications, then you need to explicitly load the jar file or deploy the jar file through the administrative console. Now let us see how to execute this. In order to execute this, first we need to compile the files, create the jar file under application. So let's go to the command prompt. First thing is, we need to set the path. In order to set the path, to compile the code, we need to go into the examples directory under domain. So we go to BA WebLogic 8.1 samples domains examples directory. Here we have two files, set examples env and start examples server. We first execute set examples env so that we can execute the build file and compile it and place it into appropriate path. So we invoke set examples env out here. The set examples env, what it does is, it sets the path variable, it sets the class path variable. Apart from that, there are several user defined variables that it creates. If we go back to our build file, we are using a variable called %applications%. Now where did this variable come from? The set examples env command file creates this variable applications and makes it point to the applications directory of your examples domain. So therefore we run the set examples env first, then we go to our application directory where we have kept all the Java files to compile. Now here we execute our build file. So I execute by saying build2. This now has created all the class files that we require under the appropriate directories. Now let us go back and look at our build.cmd file. So we should have a build directory under which we should have all these class files first. and then we would have created under the build directory the jar file. We would have compiled then using EJBC with the jar file reference a new jar file which gets placed into our applications directory. After that, we have a command to compile classes for our client. So we have said javac %client classes %. For the client, we need a remote interface, home interface, and the client class. Now this %client classes % is a variable which has been defined in the set examples env command file. What this does is places all these compiled files required by the client into the client classes directory. The client classes directory resides under server. So we have BA WebLogic 8.1 samples, domains, samples, server, examples, build, client classes. If you notice here, we have our converter home, converter class, and the converter client class. If we go back to our applications directory of our examples domain, we see that we have a EJB basic converter.jar file. Either you can create a jar file or a .ear file. Now once the files are in the appropriate place, you need to execute it. Now let us run the server first. To run the server, we go back to programs, BA WebLogic 8.1, examples, WebLogic server examples, and launch WebLogic server examples. This brings up the server. When it brings up the server, you can notice that the converter is also loaded. The component converter is also loaded. Now that the server is ready, let us execute the program. We execute the program by saying the name of the client class. The name of the client class is converter client. So we just mention Java converter client. Where is the class path set? Remember, we executed set examples env. In set examples env command file, the class path has been set for the client classes directory. So it automatically picks up the converter client.class from that class path and then executes it and gives us a result accordingly. This is how you execute your program. Now let us take a look at another example with a stateless session bean itself. Except that in this case, the client to an enterprise bean, that's a stateless session bean, is a servlet instead of a standalone application. So we will look at how to deploy our web component as well as an enterprise component out here. So here we have a calc home as a home interface, calc as a remote interface, calc bean as the bean class. We have bonus servlet, which is a servlet, and we have bonus.html file. Let us look into each one of these files. Now first of all, what we are having the user do is, in the bonus.html file, enter the social security number and the multiplier, submit it. We have submit and reset buttons. Upon submission, it calls the bonus servlet. The bonus servlet calls or looks up for the home interface. The bonus servlet will refer to the enterprise bean, the stateless session bean, invoke the method of the stateless session bean. Now let's look at the session bean, how it is written. So the home interface declares a create method which returns a calc, which is nothing but a remote interface object. Calc is having a method called calc bonus, which takes a multiplier and the bonus value, returns a double value. The bean class implements calc bonus and the other callback methods of the session bean. Since it's a stateless session bean, again all these methods are left empty unless and until you want to execute something in EJB create, EJB remove and set session context. Now moving on to the EJB jar.xml, we had declared our bean as a session bean. We called it as a stateless calc bean. The home interface, remote interface, the bean class are specified. The session bean type is specified, that's stateless. And in WebLogic EJB jar.xml, you refer to the same EJB name which has been defined in EJB jar.xml, specifying the JNDI name for that particular bean. Now the client, which is nothing but a servlet, needs to look up for that JNDI name that's called as calcs. In order to do so, again it creates a properties object, places two variables, that's initial context factory and the provider URL. The initial context factory specifies the factory name, the JNDI factory name. Provider URL specifies the URL to the server where the JNDI would be running. Take the context object, do a lookup onto a JNDI context specifying the JNDI name, which is calcs. This will return an object type that's stored into object ref. Then downcast the object to a home interface type. In the doGet method, we fetch first the parameters sent by the client and send those parameters down to the remote method. So we have get parameter of multiplier, get parameter of social security. Now once you have these values, we have also initialized one variable bonus which we need to send to the remote method. So first thing is, taking the home interface object, call the create method. The create will return a home interface, the remote interface object type. Using the remote interface object, invoke the calc bonus method, passing the multiplier and the bonus value. This returns a double value that is stored into calc and then displayed. Now in order to execute this, we have build.cmd file which compiles the code and places into the appropriate directory path. So we create again a build directory and a build with meta-inf directory. Copy all the XML files to meta-inf directory. Compile into the build directory all the component Java files, that's calc, calc home and calc bean. Move down to the build directory, then jar the contents by specifying the jar name, and the contents to get into the jar file. So we call that as std ejb basic calc.jar, and the contents that needs to get into the jar file are meta-inf directory contents and as well as all the class files required for the component. Move down to the build directory, parent of the build directory again. Compile the code to create a jar file. So Java WebLogic EJBC minus compiler Java C std ejb basic calc.jar. Using this jar file, it will generate the stub classes as well as the home object class and the ejb object classes, and create a new jar file. Place this jar file into the applications directory. Next, you need to also compile your servlet, and servlet is also a client to EJB, so all the classes of interfaces are required to be placed along with your servlet. So all that we place into what is known as ex web app classes directory. Now what is this variable pointing to? It is pointing to BA WebLogic samples server examples build examples web app directory. Examples web app is your web application directory in your WebLogic server, and this is the root of the application called examples web app. Under examples web app web application, you again have a web-inf directory which consists of a classes directory and web.xml file. Once you have compiled all this and to execute, let's see what we need to do. Let us go back here again and call the build file, which will compile all the contents for us. Once it's compiled, let us go back and check out where the files are placed. If you notice, under examples web app directory, web-inf classes, you have bonus servlet.class, calc.class and calchome.class. And under applications directory of the examples domain, we have one more class which has been added, that's ejb basic calc.jar. We need to also place the bonus.html file under the examples web app directory. So we paste it there, or we could give a copy command in the build file. Now let us, in order to execute the servlet, specify or declare the servlet in the web.xml file. So we go into web.xml file, and declare the servlet name in servlet mapping. The servlet name that we have is bonus servlet. Let's go and check up the name properly. It's bonus servlet. Let us call it as bonus servlet for the name as well, and mapping, the name again is bonus servlet, and we call it as bonus servlet /start. /bonus servlet /start, that's the virtual path. So the HTML file says http localhost 7001 examples web app / bonus servlet, because in web.xml file we set / bonus servlet as the URL mapping. Now let us save this and then go ahead and execute the contents. Now just before that, I would like to show you all the files again. In the examples applications directory we have EJB basic calc. In examples web app we have bonus.html, and then in classes directory we have rest of the classes required by the servlet, that's the calc, calc-home and the servlet class. Now let us execute. In order to execute this, we need to open to a browser window, specify http:/localhost examples web app and /bonus.html. We have an error in this file, bonus.html, so let us go make a correction there. We have to end the tag, the quote here, save it, let's go back and put that into our examples web app again, and if we were to execute this, now we get a proper output. We have social security number to enter and multiplier. So let's enter the SSN. Enter the multiplier, let's say 34, submit it. It will call /examples web app /bonus servlet. So we see that we have an error message which has come up. This is because, remember, we had already started the server and we have made a change to web.xml file. Since we are making a change into web.xml file, we have to restart the server. So let us shut down the server and then restart the server. So to restart the server, I'll go back to programs, WebLogic, examples, WebLogic server examples, and launch WebLogic server examples. Once the server starts, we'll re-execute the page. Now let us execute the page. That's bonus.html. Enter the values. The multiplier value, submit it. Now that we see an output from the servlet displaying the social security number that we entered, the multiplier and the bonus amount when calculated against the multiplier. So this is how you make a servlet a client to an EJB and execute both the web application and the enterprise application. Now let us move on to our next example, that is entity beans. For entity beans also, as we have explained through the life cycle of an entity bean, we write the home interface, remote interface, and the bean class. Let us look at an account bean. I'll take up an example from the WebLogic examples directory itself. That is, you move down to BA WebLogic 8.1 sample server examples SRC. Under SRC we have examples, EJB2O, basic, container managed, and here we have account, account bean, account home, the client, EJB-jar.xml, WebLogic EJB-jar.xml, and in case of a CMP, we have a third XML file which is the WebLogic CMP RDBMS-jar.xml. Let us go through each one of these. Let us look at the home interface called account home. Account home extends from EJB home. It has a create method which takes the account ID, initial balance and type as parameters. As we mentioned, for an entity bean, there should be a create method at least with one parameter. That is nothing but the primary key field. Others are optional. You can have overloaded create methods. In this case, account ID is the key field. We mentioned that the primary key should be a object type, and that's string here. The return type of the create method is a remote interface type, that's account. Apart from the create method, we also must have find by primary key method for entity beans. So we have find by primary key which takes only one parameter, that's the primary key field value, that's string, which also returns an account object. So apart from the primary key field, we also mentioned you can have user defined finder methods. The user defined finder methods can either return a single row or multiple rows depending on your query. If you know for sure it always returns a single row, then the return type of a user defined finder method would be just the remote interface object, a single remote interface object. If you know that at any point it can return more than one row, then the return type of the user defined finder method should be a collection type. As you notice here in this home interface, apart from the find by primary key, we have the find account method, find big accounts method and find null accounts method. In the find account method, we are taking a single double value as a parameter which returns an account object because at any point it returns a single row. Find big accounts and find null accounts happen to return more than one row, so we are returning a collection type. For each of these finder methods and create methods, we will have a EJB create and EJB finder methods in the bean class. As we mentioned, for CMP you will not mention the EJB finder methods in the bean class, but for BMP we do. Now let us go to the account.java file, which is a remote interface. Interface account extends EJB object. It has several methods, that's deposit, withdraw, balance and account type. The bean class implements the entity bean interface and it implements the methods of the remote interface along with the callback methods of the entity bean. So we have set entity context method which takes entity context as parameter. We have an entity context as a variable in the bean class here, which we set with value during set entity context method. During unset entity context, we nullify that object. Since we are writing a CMP, whichever fields that we need to persist, we need to define all such fields as public members in the entity bean class in case you are going to work with EJB 1.0. But with EJB 2.0, this has changed. That is, you define your entity bean class as an abstract class and provide the setter getter methods as abstract for each of the persistent fields. This is because if I provide public variables in the bean class, we can edit or access such fields from outside the bean class or even manipulate it through the bean class itself. The idea behind changing to abstract methods of setter getter methods in the bean class is so that only the container should handle these fields. This change was introduced in 2.0 EJB. So now let us look at all the abstract methods that are being defined out here for the persistent fields. We have the abstract get and set account ID, abstract get and set balance, and account type. These are the persistent fields. We have EJB activate method, EJB passivate method, EJB load, and EJB store. Now you do not see any JDBC code out here because this is a CMP. The container will take care of everything. So here all we have is logging statements. Similarly with EJB remove. EJB create method, as you notice here, takes the same set of parameters as the create method in the home interface. But the EJB create method returns a string. That's because the return type of the EJB create method should be same as the primary key field type. We are calling the set methods for each of the persistent fields, passing the parameter values. And finally, we are returning null from EJB create since this is a CMP. We also has the associative EJB post create method taking the same three set of parameters. The return type for EJB post create would be a void. Then we implement all the methods of the remote interface. That's the deposit, which calls the set balance method and returns by calling a get balance method. You can write out here any of the business logic content because it's a business logic method. Withdraw is setting the balance and again getting the balance. Balance method returns a balance value by calling get balance. Account type returns the type of the account by invoking the method called get account type. So these are the methods that are implemented in case of a entity bean. This is a CMP example. Now let us go to the client file. The client, as usual, needs to get the JNDI context object, then look up onto the JNDI context object the JNDI name, get the home interface object. Using the home interface object, then call the create method or the finder method to get the remote object. Using the remote object, invoke the methods. So let us see how it's being done. So we have a main function here. In the main function, we are creating an instance of the client class itself. So we have a constructor here which initializes certain variables declared in the client class, that's the URL, account ID, and the home interface object variable. To initialize the home interface object variable, we are calling lookup home. Lookup home is returning the account home object type by looking by getting the JNDI context first and then looking up into the JNDI context. The user defined method called getInitialContext returns a context object for the JNDI. So in order to do so, we create a hash table object into which we place the initial context factory variable with its value, that is the WL initial context factory, that is a JNDI factory, followed by the provider URL variable with the URL where the server is running and the port number. Create an initial context object passing the hash table object as a parameter. So once you have a context object out here in lookup home, we do a lookup for the JNDI name, which returns a home object. This home object we return back into our constructor. Now once the constructor is executed, then using the object of the client we are calling run example part A and part B, using which it will end up calling different methods of the remote interface and the different methods of the home interface. Run example part A creates one variable initial balance and account type, calls the create account method by passing the account ID, initial balance and account type. The create account method calls the create method of the home interface, passing the respective values, downcasts it to a account type, and then using this account object, which is a remote interface object, it calls the deposit method, then it invokes the withdraw method, and then finally the remove method. Please note, whenever you call a remove, it will delete a record from the table. So be very careful where you provide an access to the remove method. Similarly, in run example part B, again we fetch by using the finder method the account object, and on each of the account objects returned by the finder methods, again we invoke the appropriate methods, that is the withdraw method, the deposit method, and then finally the remove. This is an example of your entity bean. Now let us look at how the XML files are configured with. EJB-jar.xml file has enterprise beans tag with the entity element instead of a session element. Here we specify a EJB name for our entity bean, specify the home interface, remote interface, the bean class. We need to specify which type of entity bean it is, because we just derived our bean class with entity bean interface, and that is specified with the persistent type field. So we say persistent type is container, that makes it a CMP. Now we need to tell the container what is my primary key field, which are the fields I want to persist, and out of these fields which is the primary key field. And for user defined finder methods, I need to define the condition which the container needs to apply to fetch the records, because user defined finder methods, the container does not know onto which field what is the condition to place, whereas find by primary key, since you are telling the container what is the primary key field, it always automatically specifies the query for find by primary key. So the first thing that we are doing out here is we are declaring the primary key class type by saying it's a string type. We have reentrant is false here. Reentrant means to say to loop back. Whenever you have a loop back in your code, you must have reentrant set to true, otherwise you get remote exception. Ideally, we should try to avoid reentrant as much as possible, because otherwise if you have a multi-threaded client program, then the container will not be able to synchronize the information. What do I mean by loop back? Let's say I have bean A which calls bean B. Bean B calls back into bean A again, refers to bean A again. This is looping back. For example, an order has an item belongs to an order again. So this is a loop back. We are using CMP version 2.x. The fields that have to be persisted are declared with a CMP field tag, which consists of a field name as a sub-element specifying the name of the field to be persisted. So it's account ID, balance, account type, out of which the primary field is the account ID. Then we define for user defined finder methods the query using the query tag. The query tag takes query method as an element to specify a method name, that is find big accounts here. Specify the parameters for the method. So in this case, double is the parameter here. Specify the query statement for the user defined finder method. Now the query statement that we are defining is using the EJB query language. EJBQL was also introduced in EJB 2.0. Prior to this, we used to define the query language specific to a server. So if we had to port the bean from one server to another server, the query had to change. So EJBQL was introduced so that your code can be easily made portable. So for EJBQL, you specify the query inside a CData section, which is a XML statement. So the query statement is select object, that's a row, from account bean, where a.balance, A is nothing but a account bean, where the balance is greater than question mark 1. This question mark 1 means the first parameter value, that is nothing but this double value. The parameter value that you have passed here would be the value that has to be compared against the balance value fetched from the database. If it matches, then return that row, otherwise it does not return the row. Similarly, we are defining for find account and find null accounts. Take a look at this particular statement, we will come back to this later. Assembly descriptor having container transaction which says method, EJB name, the name of the bean which is for our entity bean, specifies method name as star, transaction attribute as required. We will come back to this when we talk about transactions. This is the declaration for CMP in EJB jar.xml. Now we still have couple of things left. We have to specify the JNDI name for our entity bean. We also need to specify which table I am going to store my data into or fetch my data from, and what is the connection that I am going to use to connect to the database. Now let's go to WebLogic EJB jar.xml. In this we specify the WebLogic Enterprise bean, which will have a EJB name specified with the JNDI name for the entity bean. Apart from that, there is a persistent use element defined here, that is within an entity descriptor. This is used to specify the third XML file, that is WebLogic CMP RDBMS jar.xml, because it is this file which defines where the data will be persisted into. So going over to WebLogic CMP RDBMS jar.xml, here in the WebLogic RDBMS bean tag, we define the EJB name for which we are going to define the table and the connection which it needs to use to store the information. The data source name is examples data source demo pool. Now what is this data source? You define a data source which is actually a class at the server side. You configure at the server side. Data source actually points to a connection pool. A connection pool refers to a particular connection to a particular database. We will see how to configure this in a short while. Let us first look at the rest of the instructions in this XML file. Following the data source, which basically defines my connection details, this is nothing but a JNDI name of the data source, what we have specified here. We specify the table name into which we need to place our information, and that table name here, it's called as EJB accounts. Now once we define this, we need to specify what fields in the table should the persistent variables of the bean should get into. So we need to map between the persistent fields of the bean to the table columns. To do that, we use the field map tag. Field map tag takes two elements, CMP field and DBMS column. Using the CMP field, you define the field of your bean, and using the DBMS column, you define the column name of your table to which the field has to be mapped to. So account ID content will get into the ID column, or the ID column content will get into account ID variable. Similarly, balance and BAL and account type and type are mapped together. Now let us look at executing this particular program. To execute this code, we need to specify Java, the package name dot the class name, that is client. Let us check out the class path because it is not finding the class. We got an error because we didn't have in our class path the account home and processing exception class files. So now that I have pasted those class files under the container managed directory, we execute the command to run the client. We see that the accounts are getting created and as well deleted. This is how you execute your container managed persistent fields. Now let's look at bean managed, a BMP. It's the same account example, but it is a BMP. Let us open up to account home, account, client, account bean, EJB jar and WebLogic EJB jar.xml files. Going over to account home, again we have a create method in the home interface taking the account ID and initial balance. Find by primary key, which takes the primary key field value, and we have only one finder, user defined finder method, that's called find big accounts, taking a double value and returns a collection because more than one row is being returned out here. In the account interface we have the deposit, withdraw, balance methods. Account bean class implements entity bean, declares an entity context variable and declares the variables that have to be persisted in a class as private members, account ID and balance. Set entity context sets the context object, unset entity context nullifies the context object. EJB activate, EJB passivate are just having logarithmic statements. So you notice that EJB load, store, EJB create and EJB remove methods, they all have JDBC implementation since this is a BMP. Now let's look at a EJB create method first. In the EJB create method, we take the account ID and initial balance, that's string and double. This is the associative EJB create for the create method in the home interface. The EJB create method, it gets the connection object by invoking get connection, which is a user defined method here. The get connection method returns a connection object. How does it return the connection object and where does it return from? Remember, we have a data source. We need to look up for the data source and then using the data source get the connection object. So we get the initial context object. Notice that you don't pass the JNDI factory name and the URL because the enterprise bean and the JNDI are running in the same place. So it will end up taking the default initial context for the JNDI automatically. So using the initial context object, we do a lookup for the name for the data source, and that we are calling as demo pool, JDBC/demo pool. Notice here the syntax java:/env/jdbc/demo pool. You use this when you locally access the objects. So this /jdbc/demo pool is nothing but a resource reference name which we would have declared in the XML file. We will come back to this little later. So once you have a data source object, using the data source object call the get connection method, it will return a connection object. That object we are returning back from get connection. So once we have a connection object, we call for prepare statement method. Then since it's a dynamic SQL statement to insert information into a table, we are calling for the set methods on the statement to set the values of account ID and balance. Call the execute update method, which inserts the row into a table, and at the end of EJB create method we are returning the account ID, which is a primary key, and therefore EJB create method is returning string. The EJB post create method is just doing a logging. EJB remove gets the connection object, gets the primary key field from the context, deletes that particular row, and then issues a delete statement, and then executes the update statement and close the connection and the statement again. Whenever EJB activate or passivate occurs, or whenever a user defined finder methods are called with multiple rows returned, then it will automatically call the EJB load method to retrieve each of the row details. EJB find by primary key is also defined here, which takes a primary key field value. Here again get connection is called prepare statement to select upon a primary key field, execute query, get the result set, put it into a result set object, process the result set and close the connection end statement. EJB find big accounts is a user defined finder method which takes double value as parameter. It also gets a connection, creates a statement with a select, sets the values for the condition, executes the query, processes the result set and closes the connection and statement. The EJB load method, it gets a connection, creates a statement object with the select, sets a string for the select condition, executes query, gets the result set and then processes the result set. Finally, it cleans up or closes the connection and the statement object. EJB store method creates a statement for the update, executes it, closes the connection. So this is your BMP. Let us look at the XML files. The EJBjar.xml has enterprise beans tag again with the entity element, gives a EJB name for the bean. We have a home interface, remote interface and the bean class. Persistent type has been specified as bean. The primary key class has been declared as string type. Reentrant is false. Now there is something called as a resource ref here. Anytime any bean refers to any resource like a database or let us assume even your destination object for JMS, all these are resources, right? So any resource a bean references internally has to be declared with the resource ref tag within that bean declaration tag. So inside this entity element we are declaring a resource ref because this particular bean is referring to a data source which is a JDBC connection object which is a resource. So resource ref declares a resource ref name, that's JDBC/demo pool, and this is exactly what we looked up for in the connection get connection method. Let's go back to our bean. In our bean get connection method we did a lookup for JDBC/demo pool which is nothing but this resource ref name, and the resource type is a data source. We also have defined assembly descriptor for this particular bean as well, which has been declared as container transaction with method EJB name is bean managed, method name star, transaction attribute to be required. Again we will come back to this little later. WebLogic EJBjar.xml declares the EJB name with its JNDI name. But apart from that, remember in EJBjar.xml we have defined the resource ref. We need to specify the JNDI name for that resource ref. So using the resource descriptor with the resource ref name which is nothing but JDBC/demo pool which we mentioned in EJBjar.xml, we specify the JNDI name for that particular resource ref. This JNDI name is nothing but the JNDI name that we have defined while configuring the data source at the server side. Why are we defining this resource ref? Why couldn't we just do a lookup for a JNDI name? The idea behind having to introduce this resource ref is, as a developer, I might specify some name to look up for, and the deployer actually would have configured a particular data source with a JNDI name, which might not match. So either the deployer has to go and change, or the coder has to go and make a change. So instead of this, let the developer specify whatever the name he wants to for his lookup for the resource. Let the deployer specify whatever he wants. Finally, the mapping between the deployer's JNDI name and the lookup for whatever the developer has specified can be mapped through this particular resource ref. Similarly, if one bean wants to refer to another bean within the code, let's say I have bean A and bean B. Bean A wants to refer to bean B, so it has to do a lookup for bean B. The same thing has to happen. Inside bean A, I'll do a lookup by giving some name, and that name is nothing but what is known as a EJB reference name. So in the XML file, instead of resource ref, I'll have EJB ref name. And this EJB ref name in WebLogic jar.xml will actually get mapped to a JNDI name of the bean, which the deployer would have given for the bean. So when a bean wants to refer to another bean, we need to have the EJB ref. When a bean wants to refer to a resource, then for the bean we need to specify the resource ref. This is the XML file defined for the BMP. The client class again does a lookup for the home interface, gets the home interface, calls the create or the finder method to get the remote interface, and then invokes the method on the remote interface. So this is an example for BMP.